Maybe you've heard or read about these, or perhaps you've seen or heard of words like these. This course is about all of these, and then some. Analytics and Predictive Modeling, a course on building models for big data. I'm Dr. Jeff Nicely, your instructor, a member of the Cards Institute, and this course is part of our Masters in Applied Data Science. Not surprisingly, our Masters in Applied Data Science has an emphasis on data science, the study of analytics and learning based on very large data sets, such as those each one of us produces every day. 10 megabytes of data just from your phone, if only the cell tower your phone is talking to, enabling things like real-time traffic information and personalized advertising. This is a multidisciplinary program to train professionals who can manage and manipulate potentially complex data sets, analyze their content, and, very important, effectively communicate the results of that work. This is a first step in the training of such professionals. In particular, it focuses on complex data sets by introducing the models used to study complex data sets. Of course, one model in particular is all the rage these days, ChatGPT. It's a chatbot, an artificial neural network trained to produce human-like responses to questions. It can do responses to follow-up questions, engage in conversations, and do many highly complex tasks, essays, novels, screenplays. Or more precisely, it's a large language model comprised of a generative model, a pre-trained model, and a transformer, a neural network introduced only in 2017. This GPT architecture is used to create a chatbot, ChatGPT. It's remarkably versatile. For example, what Latin phrase is close to id est idealis? This is what you get from a Google search. Not very helpful. This is what you get from a search with another search engine. I think this is Bing. Again, not very helpful. But here's what you get from ChatGPT.
The Latin phrase id est idealis is already quite close to the intended meaning, which seems to be something like that is ideal or that is perfect. However, if you're looking for an alternative phrase with a similar meaning, you could consider id est perfectum, which translates to that is perfect.
So, ChatGPT is remarkably versatile, amazing, but not very good at math. Let's take a look. Factor x cubed plus 2x plus 3. This is a high school math problem. It's very simple.
The expression x cubed plus 2x plus 3 is a cubic polynomial. To factor it, we first need to check if it has any rational roots using the rational root theorem. The rational root theorem states that if a rational number p, q is a root of a polynomial with integer coefficients, then p is a factor of the constant term, 3 in this case, and q is a factor of the leading coefficient, 1 in this case. In this case, the possible rational roots are plus or minus 1 and plus or minus 3, since the factors of 3 are 1 and 3. However, by testing these values, we find that none of them are roots of the polynomial. Since there are no rational roots, the polynomial cannot be factored into linear factors with integer coefficients. This means that the polynomial x cubed plus 2x plus 3 is an irreducible cubic polynomial over the integers and cannot be factored further using simple algebraic methods.
And yet, there we see it's factored. This is complete nonsense, but with a nice British accent. ChatGPT is revolutionizing language-based tasks. It can write full-length novels and screenplays, can write high school and college essays, translate from one language into another. It's truly impressive, a true C-3PO model for AI-human interactions, in analogy with Star Wars. but it's many light years away from being R2-D2. It's great with languages, but at this point not good with science, technology, engineering, and math. But we already have R2-D2 style models. For example, the Mars rovers. This is Curiosity. They're navigated by drivers such as Dr. Vandy Verma. However, to survive, they have to be able to act independently. To avoid rough terrain, choose smooth paths. To avoid shade blocking their solar arrays. And in order to act independently, they have to learn how to engage with their environment. The original missions were expected to last days or months. Curiosity landed on Mars in 2012 and is still in operation today. Here, for example, is the training facility for the Mars rovers. And notice that we've got a table in the back and a cable that's probably the neural network running on the computer in the back using information from the sensors that's being fed through the cable. We actually did a simulation with many area high school students, and they really enjoyed it. And we also did a similar, what we called a Smart Highways project, AI to eliminate traffic congestion. Also, computer vision is an R2-D2. It's already indispensable. We rely on it every day. Driver assist in newer cars, self-adjusting robotic arms, medical imaging. Nearly every MRI produced uses computer vision. And there are some uses we may not like. Ethics is a huge issue in AI. Data science includes all of these. So we have deep learning as part of machine learning, as part of artificial intelligence, and data science doesn't include them, but overlaps all three, including ChatGPT. Much has been accomplished already. AI is revolutionizing the world at this very moment. But there's still much to be done. Many companies, from small to large, are struggling to figure out what AI means to them, good or bad. Beginning with the most obvious question, what is all this data science? So, usually data science is used as an umbrella term for all these different areas. It overlaps all of them. And all of these are based on big data. Data too large and complex to process with traditional methods. Requires new models and methods for working with data and making predictions. Equation models, the ones we're most familiar with, are often too limited to make good predictions from big data. So we tend to use algorithms as models. And this has led to a big data revolution. Nearly 100% of the world's data has been generated since the year 2000. For example, in 2012, on average, 2.5 quintillion bytes of data are generated each day. Now, what is a quintillion? Well, million, that would be this number. If it was billion, it would be that number. If it was trillion, it would be that number. If it was quadrillion, it would be that number. But we're talking about quintillion, which is that number of bytes of data generated every day. Most is big data, enormously large data sets. Much of it exists only briefly in the cloud. Each of us generates many megabytes a day of actionable information. The Large Hadron Collider produces more than 6 million gigabytes of data every second. So why bother? Why not just stick with old-fashioned small data sets and tried and true statistical techniques? Well, big data is also very good data. Data that can answer questions we could only dream of answering a few years ago. Self-driving cars, precision agriculture, personalized medicine, personalized learning. playing games against humans and winning, leading to new technologies. For example, a competitor to ChatGPT is Llama 2, which is currently being adapted to run on WatsonX.ai, the successor to Watson that won Jeopardy. So what role does big data play in all this? Well, modern data sets tend to be very large, very complex, and also very good. So the models that are typically used are not good at extracting information. Instead, we use what are called predictive models. These are algorithmic models. They extract information quickly and effectively, produce results that can be rigorously evaluated, and they are used according to a sort of a standard approach. We explore. After all, if we explore the data and the data is simple enough, the answers we're looking for may come just from the exploration. But usually we have to do some pre-processing. We have to transform the data or normalize the data. And then we get the data mining allegory, which is that there is valuable information that we can separate from the rest of the data. And of course, we have to afterwards assess the results. As we shall see, such efforts result in highly informed algorithms that can produce truly remarkable results, like ChatGPT. But first, let's look at the structure of the course in our next video.